A 20 kilogram shopping trolley rolls down a slope of 30 degrees, and we have to determine the trolley's acceleration if the frictional force is 18 newtons. Now, to find the acceleration, we must first of all find the unbalanced force, and to do that we must draw in the force vectors acting on that shopping trolley. We know if anything sits in a slope, it's going to have a component of its weight acting down the slope. So we represent that by that yellow arrow here, and we can work out that component of weight acting down the slope is always given by the value mg multiplied by sine of the angle of the slope. That is the weight component acting down the slope. It always exists if you're sitting on a slope. Now, the other force we're dealing with is the force of friction, and we're told that's 18 newtons. Now, friction opposes the motion, always goes against the motion. So if the trolley is moving down the slope, the force of friction will be acting up the slope. So we can represent that by the white arrow there. And we know that value, we're told it's going to be 18 newtons. So if we work out the component of the weight down the slope, we can find the unbalanced force. Mg sine theta, well, that's going to be equal to the mass of the trolley, which is 20 kilograms, multiplied by g, 9.8 newtons per kilogram, multiplied by sine of 30 degrees. Sine of 30 degrees is a half, so we do that in my calculator. We end up with a value of the force acting down the slope is going to be 98 newtons. Then we can put that on the arrow like that, 98 newtons there. So there we have a picture of the two forces acting on that trolley. There is a component of weight pulling it down of 98 newtons, and there's a frictional force acting back away of 18 newtons. And you can see that the forces are unbalanced, which is going to cause an acceleration. So the unbalanced force is easily found. It's all the forces acting down the way, 98 newtons. Take away all the forces acting up the slope, minus 18 newtons like that, and we end up with a value of the unbalanced force equal to 80 newtons. Don't get hung up with the positive direction and negative directions as we do in the kinematics, vertical or horizontal. When we're on a slope, the key word is go with the flow. If the object's moving down the slope, treat that as the positive direction, as we've done here. 98 newtons down the way, take away 80 newtons up the way. So we now have the unbalanced force, and then the next step is to find acceleration. From Newton's second law, the acceleration A is always equal to the unbalanced force divided by the mass. So the unbalanced force is 80 newtons, and we're dividing that by the mass, which is going to be 20 kilograms. So then we're going to end up with an acceleration of 4 meters per second every second. Now, what does that mean? We've now worked out the acceleration. It means that trolley is going to increase its speed down that slope, and it's going to increase it at a rate of 4 meters per second every second. So after 1 second of it starting from rest, after 1 second it's going to be travelling at 4 meters per second. After 2 seconds it's going to be travelling at 8 meters per second. And after 3 seconds it'll be travelling at 12 meters per second. So you can see what's happening when we work out an acceleration. We have worked out how its speed is increasing every second. We could draw a graph of that. We could say the graph could look like this: time and velocity, and the graph would be a straight line like that. And that straight line gives you an answer that the velocity is increasing down the slope. Hopefully you know it, standing at the bottom of the slope waiting for that trolley to strike you. Here we have a 10 kilogram sledge which is sliding down a snow slope. We're told that it has an acceleration of 2 meters per second every second, and we have to determine the force of friction this time from the snow acting on the sledge. This time we have to find the force of friction. So we know the two forces acting on the sledge. We know that it's going to be the component of weight acting downwards, and that's always going to be equal to mg sine theta. So we can work that out. Mg sine theta, the component of weight acting down the slope, that's the force that takes things down a slope, is always equal to mg sine theta. And we know we have got a frictional force acting on the sledge, which we can represent by this blue arrow here like that, and we'll call that the frictional force. We'll give it a little symbol, and the symbol is going to be F like that. Now we can easily calculate mg sine theta. We can do that right away. Mg sine theta is the mass of the sledge, which is 10. times 9.8 times sine 30. Just for a simple calculation, we always make sine 30. The angle could be different in future problems. When we work that out, we have the force acting down the slope comes out to be 49 newtons. So how are we going to find this frictional force? Now we do know the acceleration of the sledge, and we do know its mass. So therefore the unbalanced force, we know from Newton's second law, is always equal to the mass times the acceleration. So if you know the acceleration of an object, and you know the mass of the object, you can find the unbalanced force which is causing that acceleration. So the unbalanced force in this case, which is causing the acceleration, must be simply 10 times the acceleration of it. 10 times 2, which is going to be equal to 20. So we've got a force of 20 newtons acting down the slope. So we now know that we can work out the unbalanced force to be 20 newtons. But the unbalanced force is given by 49 down the way, take away the frictional force back the way. So we can make up a little equation about this one then. We can say the unbalanced force, which we know is going to be 20 newtons, is going to equal to the force acting down the way, which is 49 newtons. Take away this frictional force, which we don't know. But we've got a little equation here. The frictional force, if we just swap over, take F over the other side, the frictional force is going to be 49 newtons, and take the 20 over the other side, take away 20. So we can see that the frictional force must be 29 newtons. So that's a good problem because we've not been told the force of friction this time, we have to find it out. And the plan is dead simple. Draw in your force vectors, the weight component down the slope, we can calculate that, mg sine theta, 49 newtons. The force of friction, draw the arrow in, which is always acting backwards. We know we can find the unbalanced force because unbalanced force is always the mass times acceleration. So we know the mass of the sledge, we know the acceleration of it, so we can find the unbalanced force. So the unbalanced force we know is going to be equal to 20 newtons. So if you've got 49 newtons acting down the way, the force of friction acting up the way must be of the order of 29 newtons in order to subtract 29 from 49 to give you the 20. And that's how we do that type of problem.